Hey, curious minds, get ready for mind-blowing facts about animals, science, and more. From surprising talents to bizarre discoveries, this video is packed with fun you won't believe. Sit back, relax, and let's dive into the unexpected.
Venus is unique among the planets in our solar system because it rotates in the opposite direction of most other planets, a motion known as retrograde rotation. While Earth, Mars and most other planets rotate counterclockwise, when viewed from above the Sun's north pole, Venus spins clockwise. This means that if you stood on Venus, you would see the Sun rise in the west and set in the east, the opposite of what we experience on Earth. Scientists believe that Venus originally rotated in the same direction as the other planets, but was gradually flipped or slowed down due to massive impacts or gravitational interactions. One theory suggests that a giant collision with a protoplanet early in Venus's formation may have altered its spin. Another possibility is that the gravitational influence of the Sun and Venus's thick atmosphere created intense tidal forces that slowly reversed its rotation over time. Adding to its strangeness, Venus has the slowest rotation of any planet in the solar system. A single day on Venus, that's one full rotation, takes 243 Earth days, which is actually longer than its 225-day year, the time it takes to orbit the Sun. This means that a day on Venus lasts longer than a Venusian year. However, due to its retrograde motion, if you were on Venus, a single solar day from one sunrise to the next would last about 117 Earth days. Venus's unusual rotation is just one of its many extreme features. It also has an incredibly dense atmosphere, trapping heat through a runaway greenhouse effect, making it the hottest planet in the solar system, even hotter than Mercury. Its slow, backward spin adds to the planet's mystery and makes Venus a fascinating subject for astronomers studying planetary evolution.
The idea that there are more galaxies in the universe than grains of sand on Earth might sound unbelievable, but it's supported by astronomical observations. Scientists estimate that the observable universe contains at least 2 trillion galaxies, a number so vast it's difficult to comprehend. To put it in perspective, every galaxy can contain millions to trillions of stars, and each of those stars may have its own system of planets. The scale of the universe is truly mind-blowing. Comparing this to sand, estimates suggest that Earth's beaches and deserts hold roughly 7.5 quintillion grains of sand. That's 7 quintillion, 500 quadrillion grains. While this is an enormous number, the universe easily surpasses it in terms of galaxies. And this only accounts for the observable universe, what we can detect with telescopes. The actual universe could be far larger, meaning the number of galaxies might be infinitely greater. Astronomers have gathered this data using telescopes like the Hubble Space Telescope and, more recently, the James Webb Space Telescope. Deep space images like the Hubble Ultra Deep Field have revealed thousands of galaxies in just a tiny patch of sky, proving that galaxies fill the universe on an unimaginable scale. Since light from distant galaxies takes billions of years to reach us, we're actually seeing them as they were in the past. Some dating back to the early universe, just a few hundred million years after the Big Bang. This comparison between galaxies and grains of sand highlights just how vast and mysterious the universe is. It raises profound questions about the possibility of extraterrestrial life, the structure of the cosmos, and how much of it remains undiscovered. Every galaxy could contain countless planetary systems, making the universe a seemingly infinite expanse of possibilities.
A day on Neptune lasts only 16 hours, making it one of the shortest planetary days in the solar system. This means that Neptune, the 8th and farthest planet from the Sun, completes a full rotation on its axis in just 16 Earth hours. Despite being nearly 4 times the size of Earth, Neptune spins at an incredible speed. Its equatorial rotation speed is about 2,700 kilometers per hour. Much faster than Earth's 1,670 kilometers per hour. One reason for this rapid rotation is that Neptune is a gas giant, meaning it lacks a solid surface like Earth or Mars. Instead, it is composed mostly of hydrogen, helium and methane, allowing its atmosphere to rotate freely. Interestingly, different parts of Neptune's atmosphere rotate at different speeds, a phenomenon known as differential rotation. The planet's equator spins more slowly than its poles, creating intense jet streams and some of the fastest winds in the solar system, reaching up to 2,100 kilometers per hour. Neptune's short day has significant effects on its weather and atmospheric conditions. The rapid rotation contributes to its violent storms, including the famous Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. The planet's turbulent atmosphere is driven by its internal heat, as Neptune radiates more than twice the energy it receives from the Sun, despite its extreme distance. Even though a day on Neptune is only 16 hours, a year on Neptune, the time it takes to orbit the Sun, is incredibly long, about 165 Earth years. This means that since its discovery in 1846, Neptune has only completed one full orbit around the Sun. Its fast spinning and long orbit make Neptune one of the most dynamic and fascinating planets in our solar system.
The idea that folding a piece of paper 103 times would make it thicker than the observable universe sounds impossible, but it's actually true due to the power of exponential growth. When you fold a piece of paper in half, its thickness doubles. If you keep folding, the thickness increases exponentially, meaning with every fold, the height of the stack grows at an accelerating rate rather than linearly. A standard sheet of paper is about 0.1 millimeters or 0.004 inches thick. After just 7 folds, the paper would be as thick as a notebook. At 23 folds, it would reach about 1 kilometer or 0.6 miles high. By 42 folds, it would extend beyond the Moon, and at 51 folds, it would surpass the distance from Earth to the Sun, about 150 million kilometers or 93 million miles. This rapid growth continues until, by the 103rd fold, the paper would be larger than the observable universe, which is estimated to be about 93 billion light-years in diameter. This mind-blowing result is due to the mathematics of exponential doubling, represented by the formula thickness equals initial thickness times 2 raised to the number of folds. By plugging in 103 folds, the thickness grows to an unimaginable scale. However, in reality, folding a paper this many times is physically impossible. Due to material limitations, paper can typically only be folded 7 to 12 times, even with large sheets and special techniques. The world record is 12 folds, achieved in 2012 by a team of students using an enormous sheet of toilet paper. Even though it's impractical, this thought experiment demonstrates the sheer power of exponential growth, a principle that also applies to things like population growth, computing power, and compound interest. It's an incredible reminder of how quickly numbers can escalate when doubling repeatedly.
The Sun is about halfway through its 10 billion year lifespan, meaning it is currently around 4.6 billion years old. As a G-type main sequence star, also known as G2V, the Sun is in the most stable phase of its life, where it fuses hydrogen into helium through nuclear fusion in its core. This process generates the immense heat and light that sustain life on Earth and power the entire solar system. For the next 5 billion years, the Sun will continue burning hydrogen at a steady rate. However, as it exhausts its hydrogen supply, it will gradually become hotter and larger, increasing its luminosity. Scientists estimate that within 1 billion years, this increase in brightness could make Earth too hot to sustain life, as the oceans may begin to evaporate due to rising temperatures. Eventually, when the Sun has burned through most of its hydrogen fuel, it will enter the red giant phase. During this stage, the core will shrink while the outer layers expand dramatically, potentially engulfing Mercury, Venus, and even Earth. The Sun will become much larger and cooler in temperature, turning a deep red color. After spending a few 100 million years as a red giant, the Sun will shed its outer layers, forming a planetary nebula, a stunning cloud of ionized gas. What remains will be the hot, dense core, which will become a white dwarf, a small but incredibly dense remnant of the once mighty Sun. Over trillions of years, this white dwarf will slowly cool and fade into a black dwarf, marking the final stage of the Sun's life. Even though the Sun is already middle-aged, there's no immediate danger of it burning out anytime soon. For billions of years, it will continue to shine, fueling life and driving the forces that shape our solar system. Understanding its life cycle gives us a glimpse into the future of Earth and the fate of other stars in the universe.
Yeah. The footprints left by Apollo astronauts on the moon could last for millions of years, and possibly even longer. This is because the moon lacks an atmosphere, which means there is no wind, rain, or flowing water to erode or wash them away like on Earth. Without these natural forces, the marks made by astronauts, rovers, and landers remain virtually unchanged. When the Apollo missions took place between 1969 and 1972, the astronauts walked across the moon's surface, leaving deep footprints in the fine lunar regolith, the moon's loose soil. This soil is made of tiny, sharp-edged dust particles formed over billions of years by constant meteorite impacts. The lack of moisture and wind helps these footprints stay intact because the loose grains don't shift easily without an external force. Although these prints could theoretically remain for millions of years, they aren't completely permanent. The main threat to their preservation is micrometeorite impacts. The moon is constantly bombarded by tiny space rocks traveling at incredibly high speeds. Over time, these impacts will gradually wear down and disturb the footprints, but this process happens extremely slowly compared to erosion on Earth. Another potential factor is future lunar exploration. With NASA's Artemis program and other space agencies planning moon landings in the coming decades, increased human activity could disrupt some of the historic Apollo sites. However, many footprints and artifacts from past missions will likely remain untouched for thousands, if not millions, of years, serving as a testament to humanity's first steps beyond Earth. In a way, the Apollo footprints are like a time capsule, preserving a moment in history in one of the most stable environments in the solar system. Long after the astronauts themselves are gone, their footprints may still remain, a silent reminder of humanity's first journey to another world.
About 40 light-years away, in the constellation of Aquarius, lies a terrifyingly extreme exoplanet known as 55 Cancri e, often called a super-Earth because it is larger and more massive than Earth. This planet, however, is anything but hospitable. It's a hellish world where molten lava rains from the sky and temperatures soar to over 4,400 degrees Fahrenheit or 2,400 degrees Celsius. 55 Cancri e orbits a sun-like star called 55 Cancri a. But unlike Earth's comfortable orbit, this planet is extremely close to its star, completing a full orbit in just 18 hours. This proximity makes it tidally locked, meaning that one side of the planet is permanently facing the star, while the other remains in constant darkness. The day side experiences blistering heat, enough to melt rock into lava, while the night side is much cooler, yet still extremely hot by Earth standards. Because of this extreme heat, scientists believe that 55 Cancri e has rivers and lakes of molten lava flowing across its surface. The atmosphere, if it exists, could be made of vaporized rock and heavy metals, and due to the planet's high gravity, it's possible that the vapor condenses and rains lava back onto the surface. This cycle would make for a truly nightmarish environment where molten rock constantly evaporates, rises and falls as fiery rain. Interestingly, some studies suggest that 55 Cancri e might have once been an ocean-covered world before being scorched by its star's intense heat. There is also speculation that the planet could have a carbon-rich interior, meaning it might contain large amounts of diamond beneath its lava-covered surface, earning it the nickname the Diamond Planet. Though we can't visit this super-Earth with today's technology, telescopes like the James Webb Space Telescope, or JWST, are helping scientists study its atmosphere and composition in greater detail. While it may not be habitable, 55 Cancri e provides a fascinating glimpse into the diverse and extreme worlds that exist beyond our solar system.
The largest volcano in the solar system is Olympus Mons, a towering shield volcano located on Mars. Standing at an incredible 13.6 miles or 22 kilometers high, it is nearly 3 times the height of Mount Everest, the tallest mountain on Earth. Its base spans about 370 miles or 600 kilometers in diameter, roughly the size of the state of Arizona or France. This massive size makes Olympus Mons the most dominant volcanic structure in the solar system. Olympus Mons is classified as a shield volcano, similar to Hawaii's Mauna Loa. Shield volcanoes are built up by successive lava flows over long periods, creating a wide, gently sloping profile rather than a steep cone. The low viscosity lava on Mars allowed Olympus Mons to spread out extensively, resulting in its enormous width. One reason Olympus Mons was able to grow so large is because Mars lacks plate tectonics. On Earth, tectonic plates move over hotspots, preventing a single volcano from growing indefinitely, as seen with the Hawaiian Islands. However, on Mars, the Martian crust remains stationary, allowing lava to erupt from the same spot for millions of years, continuously adding to the volcano's height and width. The summit of Olympus Mons features a large caldera, a depression about 50 miles wide, formed by the collapse of the volcano's summit after massive eruptions emptied the magma chamber. Surrounding the base is a steep 6-mile-high cliff, possibly formed by the weight of the volcano, causing the ground to buckle. Scientists believe Olympus Mons is relatively young in geological terms, with lava flows suggesting that it was active as recently as a few million years ago. While it is not currently erupting, future Mars missions may help determine whether it remains dormant or completely extinct. Its presence highlights the volcanic history of Mars and suggests that, at some point, the planet was much more geologically active than it is today. Exploring Olympus Mons would be a major goal for future human missions to Mars. Its towering height and vast lava plains make it one of the most fascinating and extreme natural wonders in our solar system.
A neutron star is one of the most extreme and fascinating objects in the universe, and it can spin at an astonishing rate. Some neutron stars rotate about 600 times per second. These incredibly dense remnants are formed when a massive star, much larger than our Sun, explodes in a supernova and collapses under its own gravity. The core is compressed into a sphere only about 12 miles in diameter, yet it contains more mass than the entire Sun. The reason neutron stars spin so fast is due to a process called conservation of angular momentum. When a massive star collapses into a neutron star, its core shrinks dramatically. But just like a figure skater pulling in their arms to spin faster, the star's rotation speeds up as its mass is compressed. This leads to some neutron stars called pulsars, spinning hundreds or even thousands of times per second. The fastest known neutron star, PSR-J 1748-2446 AD, spins at 716 rotations per second. Neutron stars also have intense magnetic fields, which cause them to emit powerful beams of electromagnetic radiation from their poles. If these beams sweep across Earth as the star spins, we detect them as pulsars, creating a rhythmic pulsing effect similar to a cosmic lighthouse. These pulses are so regular that pulsars were originally mistaken for signals from extraterrestrial life when first discovered in 1967. Despite their extreme rotation speeds, neutron stars are incredibly stable. Over time, their rotation gradually slows as they emit energy, but they can be spun up again if they are part of a binary system and steal material from a companion star. This process, called accretion, can make a neutron star spin even faster, creating what's known as a millisecond pulsar. Studying neutron stars helps scientists understand the limits of physics, as they represent one of the densest forms of matter in the universe, second only to black holes. Their extreme gravity, magnetic fields, and rapid rotation make them some of the most bizarre and fascinating celestial objects ever discovered.
Sunlight, the life-giving energy that powers our planet, takes approximately 8 minutes and 20 seconds to travel from the Sun to Earth. This is because light moves at an incredible speed of 186,282 miles per second, 299,792 kilometers per second. But the average distance between the Earth and the Sun is about 93 million miles, 150 million kilometers. Even at light speed, this journey still takes a little over 8 minutes. This delay means that whenever we look at the Sun or any other distant celestial body, we are actually seeing it as it was in the past, not as it is in real time. If the sun were to suddenly stop shining, we wouldn't notice for over 8 minutes, as that's how long it would take for the last photons to reach Earth. The sunlight we receive is produced through nuclear fusion in the sun's core, where hydrogen atoms fuse into helium, releasing enormous amounts of energy. However, the light generated inside the sun doesn't reach the surface immediately. In fact, before it even begins its journey to Earth, it takes thousands to millions of years for the photons to work their way from the sun's core to its outer layers, bouncing around inside the dense plasma. Once they reach the surface, they finally escape as sunlight and travel freely through space toward Earth. Sunlight is vital for life on our planet. It provides the energy needed for photosynthesis, helps regulate Earth's climate, and influences everything from ocean currents to weather patterns. The 8-minute, 20-second journey of sunlight is a constant reminder of our cosmic connection to the sun, our star, which has sustained life for billions of years.
Thanks for watching. We hope you enjoyed these incredible facts. If you found them fascinating, there's so much more to discover. Stay tuned for our next video, where we uncover even more mind-blowing facts about the world around you. You won't believe what's next.